So, let us discussion on the transform margins. Transform faults are essential for closing the geometric puzzle of plate motions on a sphere, allowing horizontal sliding between plates. This is named by Wilson in 1965. They include both oceanic fracture zones and major continental faults. So, let us have a discussion on the continental transform zones, which act as large strike slip faults like horizontal motion. Unlike oceanic transforms, these faults are not typically labeled as plate margins because they may lie within plates rather than between them. Let us know the formation mechanism. In that, first one is transgression, which occurs when plates collide at an angle and produces a combination of compression, that is thrust faulting, and the latter motion, which is known as strike slip faulting, and the crustal escape tectonics. In continental collision, like example India and the Asia, the colliding block, that is India, penetrates into the Eurasia. This forces surrounding continental crust to escape laterally. So, which results in the development of large scale strike slip faults on the flanks, like example Altin Tag, Red River and the Kunlun Falls. Examples of this India-Asia collision are: a prime example of continental transform tectonic produces widespread deformation including thrusting in the Himalayas and lateral faulting across Central and the East Asia, and the continental transform zones are large strike slip fault systems formed by the oblique collision or lateral crustal extrusion as seen in the India-Asia collision, though they often lie within plates and are not classified as the formal plate boundaries. Geometric irregularities in major strike slip faults create localized zones of compression or extension, forming distinct structural features like thrust or pull apart basins. Let us have the types of faults bends and as well as their effects. So, fault bends can affect how the land moves and changes. A restraining bend happens when the motion on a fault pushes the land together. This causes compression, which can lead to the formation of thrust faults, folds and uplifted blocks such as mountain ridges. So, let us have the discussion on the features of the pull apart basin. The pull apart basins form in areas where the earth's crust is being pulled apart along strike slip faults, especially at releasing bends or when fault lines overlap. These basins are known for their rapid sinking and high rates of sediment buildup. They are often some of the lowest points on the earth's continents. For example, the Dead Sea lies around 400 meters below sea level and the Tarfan depression in China is more than 100 meters below sea level. So, these basins form in response to horizontal movement along faults and show how powerful tectonic forces can reshape land. Let us have the discussion on the process overview from rift to transform. So, the transformation from continental rifting to mid-ocean transform faults involve several stages. It often starts with large strike slip faults forming within continents, as happened during the breakup of the Pangaea. As rifting continues, mid-ocean ridges form, such as between North America and Africa, followed later by South America and Africa. Let us have the examples of this type. So, the key example is Atlantic Ocean opening. The Atlantic Ocean formed as Pangaea broke apart, creating a new transform faults to connect newly formed spreading ridges. The passive margins developed along the edges of rifted continents. Some of the Atlantic Ocean's current transform faults, like the Romanche and St. Paul faults, began as continental strike slip faults and the latter became true transform faults during the formation of the ocean. Let us have a discussion on the important topic like triple junction. A triple junction is a place where three tectonic plate boundaries meet. These boundaries can be of any type, that is rift, either that is divergent, subduction or convergent, or transform, that is strike slip. So, these junctions are important because they are active and the dynamic areas of the earth's crust. So, triple junctions, the most common type of triple junction is where three rift zones meet. These usually form above mantle plumes, which are areas where hot material rises from the deep inside the earth. So, triple junctions are important because they often led to the breakup of continents and the formation of new oceans. However, not all rift arms succeed. Some stop developing and are called failed rifts or alakogens. So, let us know about the significance of the triple junctions. Triple junctions are important because they often mark the beginning of the continental breakup. They help scientists understand how mantle plumes interact with the crust and how new ocean begins to form. Not all rift arms in a triple junction become successful, showing that continental breakup is not always symmetrical or predictable. Let us know the modern relevance of the plate tectonics. Plate tectonics helps us understand many important earth's processes. It explains where earthquakes and the volcanoes happen and how mountains are formed and how oceans open and close, and this theory also explains both the past and the present activity of the earth's surface. Today, plate tectonics is a central idea in earth science and is used widely to understand geological events. Though it has a successful story, it does have the limitation. However, plate tectonics may not fully explain what happened on the early earth. During the early stages of the earth history, the planet was much hotter due to leftover heat from its formation and more radioactive decay. At the time, the outer layer of the earth may not have been solid or divided into plates as it is today. Let us have the implications of the plate tectonics for earth scientists. For scientists studying earth's history, plate tectonics is a powerful tool to explain how the earth has changed over time. But when looking at the oldest parts of the earth's history, such as the Archean or Hadean eons, they need to be careful. The earth back then was very different, so applying modern tectonic ideas without adjustment may not work. In those cases, scientists must also consider other models that fit the unique conditions of the early earth. Summary. The theory of plate tectonics, developed in the 1960s, revolutionized our understanding of Earth's surface dynamics by proposing that the lithosphere is divided into rigid plates moving over the ductile asthenosphere. These movements are driven by mantle convection, slab pull and ridge push. Earthquakes and the volcanoes occur primarily along plate boundaries like divergent, convergent and transform. And the lithosphere, which includes the crust and the upper mantle, behaves elastically in the short term but flows plastically over a period of geological time. The low velocity zone, which is known as LVZ, which lays or stays beneath the lithosphere, facilitates this movement due to partial melting and ductility.